Ladies and gentlemen, please welcome to the stage Ian Mitchell.
Hey, thank you. Good morning. Good morning, London. Welcome to AU London. Now, this is going to be an entertaining 5 minutes because we're a little late. I apologise for that. So I'm going to fast track. I'm going to go off script and go as quickly as possible to give you some time back. So if nothing else, this will be kind of highly amusing. Okay, so let me try and remember everything I want to say. First of all, we have so much for you to look forward to. We have main stage today and tomorrow from key Autodesk execs and customers. We have the breakout sessions, the technical labs, certification classes, exhibitor stands, the Autodesk Future of Making showcase. So much to inspire you and have you provoke your thinking and have you think differently about what's possible in the design and make space. All right, a few points of order very quickly. If you please wear your badge at all times, you'll need to do that. Bring your photo IDs tomorrow. There are no fire drills planned. If the fire alarm sounds, please evacuate as quickly as possible. Download the AU app if you haven't already. We need your feedback on those sessions. It helps kind of shape future events. Get involved in the conversation, right? So here's how to get involved using the app as well. Any questions, ask the events team. Want to do that? And I actually forgot to do this yesterday in rehearsal. I want to thank the sponsors. So just please, a round of applause for the sponsors that helped bring the event to you. It is kind of the main reason I'm here, and I can't believe I forgot to do that. Okay, we're going to go quick. Right, so university, it's hard to get into, right? So if you've seen this before, if you've been here before, the now traditional customary mass audience intelligence test, you all need to participate. So it's like a mass entrance exam. How this will work, it's multiple choice. You've got 3 potential answers. So you've got at least a 1 in 3 chance of being right? And as long as most of you get it right, then you're all allowed to stay. Okay, so that's basically the setup. Okay, so we're going to go quick. So I am a game show host. All right, you're on a game show with me. You've got to the final. So no pressure, you're already doing well, right? You got to the final. You're trying to win a sports car, all right? I show you 3 doors. You come up on stage. I show you 3 doors. Behind one of the doors is a wonderful sports car. You're trying to win this, right? Behind the other 2 doors are mountain goats, all right? So let's reasonably assume you want to win the car and not a mountain goat. I think that's a safe assumption, okay? So I invite you to choose a door. So let's say, for the sake of argument, you choose door number 1, all right? And here's the twist. Before I open the door to show you whether you've won, then I tell you that I'm going to open another door. So I go to door number 3 and I open it and I show you one of the goats. Interesting, right? So now here's the intelligence test. Here's the question for you. It's a 3-point question. How do you improve your odds of winning the car? So, do you want to stick with your original choice? No show of hands yet, we'll get to that. Stick with your original choice. Are you better off swapping to the other door, i.e. door number 2? Or does it not make a difference? Okay, so here's the setup. I want you to commit to an answer in your head, right? Forget what everybody else says. You might be the only person to vote for one of those options. Right, so quick show of hands and I'll get out of your way. Okay, who thinks they're better off sticking with their original choice? All right, a fair few. Who is absolutely convinced that you're better off sticking with your original choice? A fair few, all right. Who thinks it does not make a statistical or probability difference? Who thinks it doesn't matter whether you switch or swap? All right, a fair few of them. Okay, and who thinks it does matter and you're better off switching to door 2? Who's going to switch to door 2? A fair few of hands. They're so wrong. Okay, who's absolutely convinced that switching to door 2 improves your odds of winning? All right, so there is a right answer. It does make a difference. So forget the events team asking those questions. If you have any questions, talk to the people who had their hands up last. It's statistically better off to switch doors. You want to switch to door number 2. Your odds of success rise from 1 in 3 to 1 in 2. Now, I know you're all looking at me like I'm kind of crazy. It's actually true. It's caused a lot of discussion in mathematical and statistical communities, your probability goes from 1 in 3 to 1 in 2, you're better off switching. Okay, it's called the Monty Hall problem. If you're interested, don't argue with me, but I actually don't care at this point. Go and Google Monty Hall. He's a game show host from the Americas in the 70s and 80s. He used to run this thing, caused a lot of discussion. All right, so I have just enough time to say on behalf of Autodesk, of our sponsors and everyone involved in bringing AU London to you this year, we hope you have a truly stimulating and rewarding couple of days. Thanks for your time. Have a great couple of days.
Ladies and gentlemen, please welcome to the stage Sam Ramji.
Good morning. Welcome to Autodesk University. It is a privilege to host you here. So, what does the future look like? An economist might say that automation is going to take half our jobs. A journalist might point you to a bleak headline about a grim future. A technologist like me might point out that, dismal headlines sell more advertising, and only technology can save us. So the truth probably lies somewhere between. I've spent my entire career in software working on middleware, interoperability, and cloud computing at companies like Microsoft, Apogee, and Google. Mostly, I've worked on software that powers software, bits that talk to bits. What inspires me about this community is that you use software to make things, bits that move atoms. That's why I chose to join Autodesk and all of you, and to help build Forge, a platform that helps you move bits that move atoms. So I see how your work has a tangible impact on the world. I know that although technology can be a positive force, there are forces pulling in the other direction. So we worry that a growing population is inevitable, that a world with more automation to deliver more things is inevitable. We fear there'll be less jobs and less resources available on the planet. So as much as we accept the inevitability of more, we still struggle to address the inevitability of less. What do we know about the future with any certainty? Well, we know there are going to be more people. The population is growing fast. And the middle class is growing quickly too. Last year, we reached a tipping point. The Brookings Institute reported last September that for the first time since agriculture-based civilization began 10,000 years ago, the majority of humankind is no longer poor nor vulnerable from falling into poverty. While there are many definitions of the middle class, many experts agree that over half the world's population is now in the middle class. That is enormously good news. We also know that with more prosperity comes more demand for motorways and mobile phones, education and energy, housing and hospitals. So more is inevitable. How can we make all we need and do this with less negative impact? Less negative impact on the planet, less negative impact on the people. So in order to solve this fundamental capacity problem, we have to fundamentally rethink the way we make things. Balancing the inevitable need to do more with the reality of doing it with less. Right? That's a massive design challenge. So addressing a challenge of this enormity and complexity is also the biggest design opportunity we've ever had as a society. Our technology helps you with design challenges every day, automating how things are designed in the digital world and made in the physical world, which is why we believe that along with the inevitability of more and the reality of less is the opportunity of better. The opportunity for a more balanced, more sustainable, and more equitable world. Better for the growing middle class, yes, but also better for those still in poverty. So design challenges don't get much bigger than the one that faces millions of displaced people around the world every year. Imagine if you had to build a city for 600,000 people in just 6 months. That was the size of the challenge that Phoebe Goodwin faced. Phoebe is the site architect for UNHCR, the United Nations High Commission for Refugees. And 2 years ago, her job was to rebuild this community, Cox's Bazar in Bangladesh. Cox's Bazar grew quickly as Rohingya refugees fled persecution in Myanmar. In 2017, they reached this refugee camp and many like it. In the last 4 months of 2017, Cox's Bazar grew sevenfold into a community with 600,000 people. Now, to put that in perspective, that's about the size of Bristol or Dresden or Lyon. So the growing number of displaced people put, as you can well imagine, an accelerating burden on the site's infrastructure. So that's why UNHCR and Phoebe got involved. Now, by the time she arrived, the community had already grown substantially in this rugged terrain. You'll note that the real world is made out of 3 dimensions, which has an impact in monsoon season. So spontaneous settlements were causing problems with existing services already. Sanitation, safety. The refugees need wood in order to cook. They burn the wood for fuel, for safety, for comfort, for heat. Deforestation of the surrounding area made it vulnerable to mudslides, especially in the monsoon season, which was only 6 months away. Phoebe needed to plan how to build a more resilient community quickly. So she began to plan the changes the site needed. Where should shelters be moved? Latrines, roads, bridges, where do those need to be placed? Where are the paths located in order to keep people safe? Planning efforts on site often begin on paper, but Phoebe knew that she needed faster, better insights. After all, a flat piece of paper is not a great place to model a complex 3-dimensional topology. It's a challenging, mountainous location, as you can see. So she turned to software that we donated into the available terrain data. And then she turned to Microdesk, an Autodesk partner. Microdesk trained the UNHCR team how to import the 3D data and use it in Civil 3D. They showed how it could save time and deliver better insights. So Phoebe could now simulate the monsoon season's impact to discover where flooding and landslides could be expected. She automatically generated floodplain and floodway maps, which were enough to persuade the local government that they needed heavy machinery to build substantial earthworks. Phoebe used bits to move atoms. Her digital work had a tangible physical impact. The UNHCR team was able to remodel critically at-risk areas and move the shelters, over 100,000 of them, to higher ground, safer ground. Of course, the inevitable monsoons came, and so did more people, but there was less negative impact on the site and its occupants. Phoebe was able to build a city for 600,000 people in a matter of months instead of years. A city that provides safe refuge, sanitation, basic infrastructure, and a better quality of life. Phoebe was able to seize the opportunity to make a better plan for the monsoon season. Because she used simulation, she discovered better insights, better shelter locations, and a more resilient community, a better community. So if simulation can help us build a more resilient community for 600,000 people, what can it do for the rest of us? For those of us who work in everyday companies, doing everyday jobs and making down-to-earth decisions. It doesn't get much more down-to-earth than cement. Cement is the key ingredient in concrete. Concrete is used, as you know, everywhere, in buildings and bridges, drains and dams. Claudius Peters is a German company that makes the heavy equipment to build cement. They've been making cement grinding mills, conveyors, and coolers for over a century. While the company dates back to the industrial age, they are moving quickly into the future. So they're exploring how can they evolve their industrial machinery? How, by making it more efficient, can they save their customers money? How can they reduce the negative impact of cement production? Because as harmless as concrete seems, it's actually a big emitter of greenhouse gas. Think about this. If concrete were a country, only China and the United States would emit more CO2. In fact, cement production accounts for 8% of global greenhouse gas emissions. Here's the opportunity for better. 50% of this negative impact happens during the production process. Any improvements to its production will have a meaningful impact. So Claudius Peters started by looking at how it could evolve their clinker coolers. These things move 13,000 tons of clinker a day. Clinker, as I've learned, is what you get when you grind limestone and clay and heat it to 1,500 degrees Celsius. That's a lot of hot rock. Now, these pans hold the clinker as it comes out of the furnace and deliver it to the next stage in production. They have to cool that rock from 1,500 degrees, incredible temperature extreme, and think about the specific heat capacity of rock. That's a lot of energy, bringing that back down to room temperature over and over and over again. It's hard to be a pan. Now, 60 or more pans are bolted together on a series of conveyor lanes that move it through the cooler. So when you think about one of these factories, that's a lot of pans. So Claudius Peters' engineers had redesigned the pan to remove as much excess material as possible. They were pretty confident, being great engineers, that it was optimized and their design was as efficient as humanly imaginable. They'd use inventors' simulation capabilities to validate that their design would perform as expected. It's one thing to be light, it's another thing to really work. So here's where things get exciting. Their chief digital officer, Thomas Nagel, wondered if generative design could help them further optimize the pan. Could generative design make the ultimate pan? I kind of feel like the pan is the hero of this story. Using the engineering team's best design as the baseline, Thomas set up a lab to explore the opportunity. So after 4 hours, the team had its first results. Thomas called it the alien part because it looked so different from their original design. In place of the engineer's angular design was a shape that flowed in unexpected ways. If the way that it looked was unexpected, so was the impact of this process. This part was almost 40% lighter. So the engineers were suspicious if it would perform, because, hey, we're engineers. We have to be skeptical. They returned to Inventor and ran simulations to test the design's performance. And they were astonished. Not only was the pan lighter, it outperformed their prior design. So their work redesigning the pan digitally had an impact on the physical part. They used bits to move atoms. This solution, however, produced a different challenge. Generative design had produced an organic structure that could only be made using industrial additive manufacturing. So think of this as 3D printing in metal. It's expensive. There's a lot of parts. You want to optimize the cost. That's not the way. So the engineering team had to figure out a different manufacturing strategy. Within a week, the team had managed to reverse engineer the parts. So the pan can be made using more traditional techniques, going backwards and forwards in Inventor, adapting the design, and simulating its performance. They discovered a solution that could be welded together from laser-cut steel plates. This new pan would be 25% lighter, faster to make, and less expensive, about 100 euros cheaper per pan. Because the new design is substantially lighter, they also save on shipping costs. So think about the laser-cut steel welding. They used to use casting. Their old pans were cast in Turkey or India, where coal is a dominant fuel source. So because a new pan can be made in more places around the world that are less reliant on coal, you also have lighter parts being manufactured locally, reducing the carbon footprint. So evolving the performance of this pan is one small portion of the investment that Claudius Peters is making in improving the efficiency of their coolers. They manufacture coolers that are more thermally efficient, saving the equivalent of €1 million per year compared to competitive offerings. Now think about this. Less fuel means less greenhouse gas emissions. So the Claudius Peters clinker cooler now offers the equivalent of removing over 12,000 vehicles from the road for a single production line. So this thing might be just one small piece of the puzzle, but by exploring how it can be designed better, Thomas and his team at Claudius Peters found an opportunity to make it better. The pan can be made more locally, more easily. It uses less material with less negative impact on the planet. So simulation software helped Claudius Peters gain insights into the performance of their new coolers. But it was generative design that opened up the opportunity for them to make better things in better ways. So as we saw, simulation is a powerful tool that can produce powerful insights. When you run a simulation, you discover insights into the design's performance. The problem, as Claudius Peters will tell you, is that it's extremely compute intensive. So in fact, every time that you double the resolution of a simulation to increase its accuracy, the computing requirements increase by a factor of 8. That's our old friend, the square cube law. So the time required for one computer to simulate one design could actually generate you 100 options on 100 cloud compute nodes. There's so much computing power in the cloud that you can even flip design and simulation around, not just simulating your existing design, not just simulating to validate a new design, but actually simulating to discover the design. With generative design, you just need to describe the problem, the constraints, the goals, the forces at play, and then our technology helps you discover what's possible. It uses cloud computing to analyze the entire solution space, discovering designs you would never imagine, so you can select the ones that you really want. So, for example, what's the optimal design for a space vehicle that might land on one of Jupiter's moons? This is a concept design for a lunar lander. We revealed this at Autodesk University Las Vegas last November. We brought it here so you can see it. Seriously, it's really cool. Go see it yourself. It's just outside the door. It's the work of NASA's Jet Propulsion Laboratory, or JPL, who used generative design technology as a new way of designing things. So JPL designers are also really interested in exploring new ways of making things. They have some harsh conditions to deal with: outer space, high temperatures, low temperatures, the stress of landing. So like Claudius Peters, JPL can't use additive manufacturing. Not because it's too expensive, because, hey, this is a government space program, but because it's too early. It hasn't been qualified for space travel. So the idea of 3D printing this lander is still science fiction. However, JPL can 3D print molds and use the molds for casting, and that's exactly what they did for the lander's chassis. Now, the lander's legs, on the other hand, are optimized to be milled. It's a better approach for managing the stress of landing. So by adding algorithms into Fusion, that would allow us to constrain the design output for specific methods of manufacturing, such as 3-axis and 5-axis milling. Autodesk is giving JPL the opportunity to design all sorts of parts better and to manufacture them in ways appropriate for their needs. Many new ways to design, many new ways to manufacture. Generative design is now practical for JPL, and it's practical for Claudius Peters, and we are committed to making it practical for each of you. Our last story brings us back from outer space and down to Earth with a bump. So as we make more things for more people on Earth, we risk making things worse, not better. Worse for the planet, worse for the people. There are 18 million people working in construction in the European Union. They contribute almost 10% of the EU's GDP. So it's an important industry. It's also a risky one. Over 800 construction workers die each year on the construction site in the EU. In the United States, that number is about 1,000. At the same time, we build over 11,000 buildings per day worldwide. By 2050, and 10 billion people on the planet, we're going to need to produce over 14,700 buildings per day to serve this larger population, to have enough homes, enough hospitals, enough schools to house, heal, and educate our people. So construction projects generate a constant stream of data that could be real-time analyzed. You could make real-time decisions. So as we construct more buildings, the opportunity for improvement is to analyze this data and improve the quality of the product and reduce the number of accidental deaths. So how can we increase the rate and quality of construction for 10 billion people while also making construction safer? Traditionally, we think of this as the job of the site manager, and that is a hard job. This job can be very reactive because it lives in the world of atoms. Atoms move very fast, and the risk is high. So how can we understand all that complexity at the speed we need? The answer resides within the enormous stores of compute power in our grasp. The site managers at Royal BAM Group are applying vast computational capacity to analyze all of this data. By analyzing their history, they can see the future. They can look at that data and predict risks. So just a few years ago, Royal BAM collected their data, like most companies, on paper. Today, Royal BAM's data collection is 95% digital. Now, getting there wasn't easy. They started the process in 2017, digitizing their existing process. They learned a number of interesting things. Most importantly, they were storing a lot of historical data, but 90% of it was never used for analysis. So the team understood, by looking at the past, they might predict the future. So with the permission of Royal BAM and many of their peers, Autodesk collected millions of data points. This real-world data presented an opportunity for construction companies. We built Construction IQ using over a decade of construction data to better predict and manage risk. With these tools, Royal BAM applies machine learning and predictive analytics. They spot patterns and they predict high-risk issues that could impact the safety of their workers. In addition, Royal BAM incorporated data from other sources, combining it with their BIM 360 solution. I think this is particularly cool. The team pulls in photos from cameras all around the job site, and they use Autodesk partner and developer smartvid.io to integrate this and analyze the imagery for risk. The integration happens through the Forge API, and they combine that analytics with their BIM 360 solution. So smartvid.io connects this imagery to other data and other data streams to help Royal BAM understand the risk to their workforce. So not only does Royal BAM identify the financial and quality risk associated with certain subcontractors, they can now also identify the safety risk associated with missing scaffold guardrails. The team gets much more value from their data in new ways like this. So today, Royal BAM is analyzing data to predict risk, delays, and cost overruns digitally using BIM 360. The job site managers are more productive. They close out safety and quality issues 20% faster. They have better insights to ensure less rework, making their sites safer, more predictable, more productive, and more profitable. So these sites are less risky for their workers and for their business. The computational power that we have today offers the capacity to converge the way that we design and make things. Today, the way that something could be made is starting to drive how it should be designed. So we want to give you a clear line of sight from design to make, from part to production. You want to better understand the different options that you have. How could your designs be made? You want to understand the different material choices. What is the embodied energy, right? What are the costs in each design option? In addition to the capacity to converge the way that you design and make things, imagine if we could give you the capacity to connect them as well. If you use this computational capacity to connect your design challenges and your production challenges, think of the insights you could discover. If you could see supply and demand for your raw materials, for your labor, imagine how much more balanced you could make the world. Part counts, recycled materials, staffing. You could bring your industry towards peak efficiency, a circular economy. Together, if we help construction become more predictable like manufacturing, and manufacturing more flexible like construction, we can help you become more efficient and further reduce waste. By converging and connecting what you design and make, this computational capacity makes it possible to imagine and better see what you're really trying to accomplish. So Royal BAM saw the opportunity to better manage risk and create a safer workplace. Their data insight let them balance the profitable with the predictable and increase human safety. JPL saw an opportunity to better design all kinds of parts and to manufacture them in all types of ways. Claudius Peters saw an opportunity not just for a better way to design things, but to find better ways of making them that would have less negative impact by using less material and less energy. Phoebe and UNHCR saw an opportunity to improve the lives of 600,000 displaced people by giving them a better plan for a better community. What opportunities do you see? You understand the impact of your work on the world. Imagine the impact you will have with limitless computation. Imagine applying this capacity to the problems that you wrestle with. Together, we're exploring the opportunity to make the world more balanced, more sustainable, more equitable. Let's make a better world. Thank you. Now we'll hear from Matt Gough, Director of Innovation at Mace. The company has been leading the industry with amazing ideas made real, like the Rising Factory, a fantastic demonstration of thinking big to try and solve some of the world's most pressing problems: urbanization, sustainability, and labor availability. Please join me in welcoming Matt to the stage.
So, good morning, London. It's my pleasure to welcome you to this amazing city this morning. And my pleasure, as the Innovation Director of London's top contractor, to be able to share with you how we're embracing the opportunity for better at Mace. I'm going to talk to you about the acceleration of our digital transformation, the acceleration of building buildings, and importantly, our collective role in doing so responsibly and sustainably. But first, we need to go back a few years. Mace is an international construction and consultancy company founded in 1990 in pursuit of a better way for delivering construction projects for our clients. In 1998, when Egan was encouraging us to rethink construction as a manufacturing process, Mace was already exploring the opportunity for convergence to deliver the London Eye to a programme and a budget that the rest of the traditional UK construction industry had told us could not be achieved, had told our client could not be achieved. Sorry. We saw a better way. In 2011, we were completing London's tallest building, the Shard, safely and to a rate of production not achieved before in the City of London. We did so by applying both digital and off-site prefabrication techniques to test, prototype and assemble all of the building's most complex elements, a great case for convergence. And we continue to innovate in order to deliver enhancements to London's skyline. Any football fans in the room? We've recently completed Tottenham Hotspur's world-beating new stadium, a mega project in which 30,000 unique operatives were inducted over a 3-year programme. We're midway through turning the power back on at Battersea Power Station, a £1.6 billion transformation of one of London's most iconic buildings. There's 19 tower cranes on that site alone at present. But for today, our innovation case study really hones in at the site of one of Mace's most significant success stories, the Olympic Park, home of the London 2012 Olympic Games. Following the success of London 2012, Mace has continued a role to help transform the park into the fantastic legacy that it is today. In 2014, we were appointed by our client, Qatari DR Delancey, to build N08, a twin-tower development and podium building that delivers 480 much-needed new homes for Londoners. Designed traditionally, procured traditionally, but built using a radical new way of construction, a first for the UK. Our project team at N08 were tasked with changing how we build. There were a number of project risks to be mitigated. Accidents when working at height continue to be the biggest cause of fatalities within our industry. We had some challenges with the wind, particularly in East London, which stops cranes and causes programme delay. And importantly, when delivering residential, the critical path always gets stuck with the fit-out. You simply can't start laying carpet until you've got the building weathertight and stopped the rain coming in. So our team found a better way. At the top of those towers, you can see our 2 rising factories, 600-ton steel structures that sit at the top of, that jump as each floor of the building is completed. They're roughly the size of the Tower of London, each of those. That jump, in order to lift them, when activated, is the equivalent of a space rocket taking off, our very own Mace X. And inside the factory is a very different environment in which to build. We're about to go in one. This video is shot 100 meters up in the air, although you wouldn't necessarily be able to tell. And it shows a standard sequence for our construction operatives to install a residential floor. So in the top left, you'll see a clock counting down from 55 hours, Monday morning to Saturday lunchtime. a working week on site, and how quickly we were finishing a residential floor plate. What you can see is a sequence of bringing in a number of industry standard components, such as precast concrete columns and twin wall. What is unique is not the product, but the sequence and the process in which it is being delivered. This is not a construction site, this is a factory floor. You will note that there's no tower cranes. All lifting is taking place via a set of high-powered gantry cranes that allow us to lift bigger elements, up to 20 tons, unrestrained by the wind. There's some MEP modules which are coming in a minute. They're much larger than we could normally lift, and they provide the entire horizontal MEP services to the floor plate, installed in just 30 minutes. Just about to come in now. You will also spot that there's not many operatives on the working deck. We've got a real challenge on labour availability within our industry. And at N08, we were able to reduce the number of operatives, the amount of labour required on site, for 4 of the 5 major packages by 50%. And in terms of safety, there's no leading edge. So the factory entirely removes the requirement for working at height, and there's no chance of dropping anything. Just some of the many benefits achieved. Once we got going, we built 18 stories of residential in 18 weeks. The 2 towers were completed 30% faster than any of the traditional construction market had achieved in the UK. It was our safest high-rise project, with over 2 million man-hours completed without an incident. We were more productive, and importantly, we reduced our impact during the construction process significantly. Off-site consolidation led to 40% less vehicle movements during construction. That's less impact on the roads, less impact on local residents, and less pollution. And we managed to reduce the waste on site by 75%. Our project team at N08 saw a better way, and were able to achieve some industry first by changing their mindset. They challenged everything about how they thought the construction of a high-rise should be completed, and achieved a phenomenal result. This man here is Dave Bones. He's in that team. Dave is one of our senior construction managers. He's been in the industry for 40 years. You're all a bit fearful of the stereotype of Dave. He's one of those industry dinosaurs. He doesn't like change much. So what about technology? Don't fancy doing that. But here at N08, our Dave is embracing innovation with both hands. So one day on site, Dave runs into the project office, panicked, flustered, a bit put out. "What's the matter, Dave?" asks our project director, fearing the worst, a fire, an accident on site, something serious. "Tony, there's loads of traffic today. The crane's decommissioned. I'm 12 minutes late on my fit-out delivery." 12 minutes late. Not hours, not days or weeks, or even months like the delays we face on some capital projects, but Dave is thinking in minutes. It's a different mindset, a different way of thinking to deliver construction. Across the globe, our people at Mace are employing that different mindset in order to develop, adopt, and deploy technology across all parts of the project lifecycle. In Ireland, our teams have digitized, connected, and integrated the entire construction workflow, from design right through to operation and handover, using the BIM 360 platform. We've made people's work easier and more efficient by democratizing data and integrating all of our on-site processes. That has accelerated people's work. Our site managers and operatives are saving up to 8 hours a week, a 32% increase in their productivity. We're also pioneering the use of BIM 360 Plan for our on-site planning and production control. Technology is allowing us to plan in greater detail, increasing from 150 tasks a week using paper to 350 tasks using digital. Greater detail offers greater integrity, and our percentage of work completed has increased accordingly, from 71% to 80% of planned tasks. So we're not just tracking more, but we're completing more work more consistently, using technology as the enabler. More closer to home, just over the river from here in Greenwich, our on-site teams are scanning and validating all completed works, comparing what's been built versus what should have been built. On the piling alone, we've reduced the cost of error by 72% by identifying and resolving errors in real time. And globally, across our projects, we are more efficient and more productive every day through the use of technology. We're flying drones, using VR, AR, 360 cameras, sensors, automation. We're designing, estimating, and delivering in digital. And we're handing over better quality projects as a result. And to do that, we're empowering our people with technology. Across our 6,000 staff globally, we are completing a program of training in all aspects of digital, from 3D coordination through to 6D operations. Across our supply chain, via our Mace Business School, we are training the industry to be better at tech. From MBA-level courses for our supply chain's rising stars, to digital basics on our sites and our offices worldwide. And the result is that we have a more empowered workforce, a happier workforce, that are driving up our productivity and delivering better outcomes for our clients. Yet, while we are achieving great things by applying technology to do those things better, we also recognize the need to do better things. There are many reasons that we need to change as an industry. Rapid urbanization, the environment, poor productivity, labor availability. We all know the list, right? But our industry is digitizing fast, and that puts us on the cusp of a significant, once-in-a-lifetime transformation of our industry. The entire game is changing. Our response at Mace is moving from construction to production. We see a near future where we will design, manufacture, assemble, and operate the built environment that we are responsible for in a very different way. We'll be faster, safer, leaner, more predictable on outputs such as time and cost, and better. By 2022, 85% of Mace's projects will be manufactured and assembled 50% faster than our 2017 baseline. And our clients are going to be 100% more delighted with the outcomes. The business model, or this business model, is going to be enabled by technology. We're now well underway with building the ecosystem that will allow us to transform. How we engage our supply chain will be radically different. We're taking a lot of learning from the retail sector, and we'll have full end-to-end visibility of all supply chain activity, from order through to operation. We will control our on-site execution and assembly processes far more efficiently with integrated logistics and material management, plug-and-play assembly, real-time site execution. And most importantly, the customer and end users will be at the center of our future production system. Client configuration will enable more agility in the design stages. Our platform enables real-time transparency across the entire project lifecycle, so the power of project status and performance is in everybody's hands. And digitized buildings and smarter assets mean an ongoing rich relationship between the built environment and its users, giving us the data to continuously improve all aspects of the project lifecycle. In doing so, we will unlock the power of our organization and the wider industry to guarantee a better outcome for our clients. And by this, I don't mean those traditional construction outputs that we all love measuring so much. A bit faster, a bit lower cost, a few less defects. That's that nasty but necessary CapEx thing that a lot of people aren't too worried about. I'm talking about operational outcomes, the purpose of the buildings that we're all responsible for creating day in and day out. Okay, remember Dave? Now, I'll be honest, I have to deal with a few Daves in my day-to-day too. We all know a Dave, right? Close your eyes, picture him, you probably see him now. Turns out not everybody is that fussed about business model transformation or technology adoption. But the good people, Dave included, definitely care about outcomes. Better education for kids, better productivity for office workers, better healthcare for patients, better journey times for commuters. You see, all this transformation and change only really works when your people believe in it, drive it, champion it. And that is what is accelerating our thinking at Mace, where we're putting our purposeful approach into practice already. Working for a major Whitehall client on their 10-year estate strategy, we've identified a 10% capital cost reduction and a 20% OPEX improvement across a £4 billion programme. We're rethinking design, thinking about the estate as a suite of standard design platforms and putting our focus on product development to help them realise a brave new approach, which is cool. But the real outcome is going to be more available, more suitable, and more sustainable accommodation for servicemen and women way into the future. Our next iteration of the Rising Factory is now in production. It doesn't involve a factory, but it does involve faster construction at reduced costs by integrating floor and facades into modules and applying all of the innovation multipliers from the factory. We're vertically integrating our supply chain. We're working in a better, more collaborative way with our clients, architects, and designers. And the real outcome is going to be more, better homes for Londoners, faster. And we're also deploying technology across our commissioning and facilities management projects to get better operational efficiency for our clients. Working with partners, we're achieving significant savings in energy use and operational expenditure. Recently, at a big bank's corporate HQ in London, we reduced the energy usage in the building by 20% a year within the first month of our contract. But the real outcome is better productivity, better well-being, better health for those employees. And as we move from construction to production, this focus on outcomes for our industry is the most important point for us all to remember. Not to be too existential, but what is our purpose as construction? We beat ourselves up about the industry, image of the industry, far too often. I mean, it is tough at times, really tough. We had a month's worth of rain in London last week in 6 hours. It's a lot of rain, it's a lot of mud. But despite that, we achieve amazing feats. We build amazing projects. We've looked at some of Mace's earlier. And we make a tangible impact on people's lives every minute of every day, be they working, traveling, sleeping, studying. You just can't say that if you build mobile apps for a living. And that's why at Mace, we're laser-focused on our vision, to be the industry leader in shaping cities and building sustainable communities, and the positive outcomes that we generate as a result. We're leaving a positive impact on the environment because this is a climate emergency, and we have a seriously resource-intensive industry. There's roughly 12 years to sort our carbon emissions out if we want to keep global warming to that acceptable level. So we've signed up to the RE100 and will remove all carbon from our operations by 2022. We're also well underway from removing all diesel from our sites, but we can all do more. We're creating a positive impact on the communities we work in and around. Urbanisation and an increase in population density is now happening on everyone's doorsteps. And people's health and well-being is significantly impacted by construction. So let's do it in a positive way. Create jobs, create opportunities, champion change. And importantly for today, as a room of change makers, we need to make a positive impact in improving our own industry. We have a collective responsibility to do so. And that is why and how our people at Mace turn up to work every day, pursuing a better way for our clients, our colleagues, and our communities. And I'll just leave you on this point, which borrows from the excellent innovator Beth Comstock. Mace was founded in pursuit of a better way, and today we ask our colleagues to continue that mission. And to do so, they, and I think us, have to believe in a better way. To have an impact, which I think we're all capable of, we need to do two things. Firstly, believe that tomorrow can be better today. And secondly, that we have the power to make that so. And that's what we can do in our industry. That's our opportunity for better. Thank you.
Ladies and gentlemen, please welcome to the stage Erin Bradner.
The rhetoric of innovation paints a picture that it's either about waiting for an idea to drop out of the sky, or it's about building a fun environment to coddle creativity. The reality is that innovation is hard work. It's difficult, not because conjuring new ideas is difficult. That's part of it. What's difficult is executing on those ideas. Not everyone can execute on innovation at the incredible scale that Mace does. Yet I know you have no shortage of incredible ideas. You simply may not have chosen to dedicate the budget and the people full-time to research and development. So I want to talk to you today about 3 approaches to innovation that we take at Autodesk. We collaborate to focus our research. We cultivate conditions where innovation can thrive. And we work with customers who catalyze change in their fields by pushing our tools in new directions. I work in Autodesk Research, and it's our job to innovate, to solve problems we know you have today and we know you will have in the not-too-distant future. Autodesk dedicates considerable resources to developing new technologies. Our in-house researchers and domain experts continually invent new technologies. But working independently on our original ideas is just one way we innovate. Today, I'll tell you a few stories about how we work with others to collaborate, cultivate, and catalyze innovation so we can help you make better things in better ways. Let's start with a story about how we collaborate. It's a story that begins with a question. What do you do if you're an architect and your client loves your unique design and you have an idea for how to build it that no one has ever attempted before? This 24-meter footbridge is not made from exotic materials. Its appeal is not in its steel tubes and plates. Its appeal is in its complex angles. There are a lot of them, and they all need welding. Welders build fixtures to hold pieces in place while they work. But to do that here, you would need to build a fixture that is as complex as the bridge itself. You could call in a team of carpenters, or you could call in a team of roboticists. That's what architect Scott Mitchell did. He called Autodesk's robotics team, my team. Scott runs the architecture studio at the University of Southern California that designed the bridge, and he wanted to know whether our researchers could help him execute on his idea to use a robot to position all 500 parts in his bridge for a human to weld. Scott knew that a typical assembly line robot can take days to program just one part, so he knew the maths for his bridge wouldn't work out. If 500 parts in CAD equal 500 days of programming, then it would take over 16 months just to program his bridge. Scott was also wrestling with what sequence he should follow when assembling the bridge. He was resolved that his robotic workflow needed to be flexible about sequencing. Our robotics team was resolved about flexibility too. They had recently developed a research tool called Mimic. It's an open source plugin that brings robotic control into the familiar environment of Maya. Maya is what customers use today to control the motion of animated characters. Our team was convinced that the sequencing should be driven by Scott within this flexible environment, with the robot programming being automated by the design file itself. So they customized Mimic to automatically generate robot motion code from the 3D model of Scott's bridge. The robot knew where to move because every plate and beam knew its place in the design file. The logic in the 3D model was the same logic that drove the robot programming. Through this flexible workflow, Scott could sequence and resequence the assembly in any way he liked, as often as he liked. All that he needed at this point was a really big robot. So Scott secured a residency at Autodesk's Technology Center in Boston, and the team there helped him get set up. Now, as Scott began moving the robot, he found a couple of bolts that weren't modeled in the CAD file, and that restricted the robot's reach. In a traditional robotic workflow, this would have stalled production and caused a day or two of delays. But he just nudged the robot in Mimic and recompiled the instructions. It was no big deal. Producing the robot code to drive the robot took just 15 minutes. What the robot made for Scott was not up for debate. The bridge in the 3D file was the bridge that Scott had permission to build. But how the bridge was sequenced was flexible. Scott could adapt his strategy on the fly. People are great at creativity and common sense, conjuring ideas and making decisions on the fly about how those ideas should best be made. Industrial robots are great at precise positioning and heavy lifting. By using robots and people for what they're each good at, Scott and Autodesk created the opportunity for both parties to do what they do best, even better. With 3D design data driving his robot, Scott was better equipped to move from design to build. He learned how to better execute against his design intent and build a complex bridge with less technical friction. Plus, the learning from this collaboration went both ways. Our researchers learned how to better automate robotic assembly at civil engineering scale. Architects collaborating with technologists is a mutually beneficial approach to innovation. Let me tell you about another approach to innovation, an approach that's less about collaboration and more about cultivation. This approach is about seeding the conditions for growth and creating an environment where innovative ideas can germinate. Because although your next big idea might arrive in a flash of genius, executing on that initial spark can be a stormy slog. But when we bring innovative people into our organizations and give them a resource-rich working environment, their ideas can quickly take root. We take this cultivation approach to innovation at Autodesk. And we do this by inviting academic researchers, startups, and customers like you into our technology centers to share our space and our equipment as they explore ideas that will shape a better future for all of us. We have 4 centers globally, And we host over 300 residents in those centers every year. One resident is a startup called Overview. Overview was founded by a couple of ex-Tesla engineers, and they're residents in our San Francisco Technology Center. They're developing a machine learning vision system that watches machines on a production line and generates real-time alerts when production goes awry. Their approach is pretty simple. An inexpensive camera watches machines for a while as perfect, intolerant parts are made. And then over time, a machine learning algorithm in the cloud learns what perfect looks like. It learns from watching the correct thing being made time and time again. So if something imperfect happens, the system sees it and flags it. Now, visual inspection has been around for decades. This is a whole new breed of visual inspection. There's no pre-programming required and no hard-coded rules for exceptions. A shadow might throw off traditional inspection, but a machine learning algorithm can learn what a shadow is. And once it's developed shadow detection insight, it can apply that learning across multiple parts and any conditions. The machines in our technology centers don't know if they've made something wrong. Most machines don't. But by applying machine learning, the overview system can spot errors when people aren't available or aren't trained to spot them. Through the Technology Center residency, Autodesk is helping cultivate Overview's ideas. They own the innovation, we don't. But our manufacturing customers stand to benefit if they successfully execute on this budding technology, since it likely means less money wasted on defective parts and more machine uptime for manufacturers. Overview is just one of the residents we're hosting in our San Francisco Technology Center. The center is focused on the concept of the reconfigurable microfactory. And the Boston Technology Center, where Scott built his bridge, is focused on digital fabrication and construction automation. And our Birmingham Advanced Manufacturing Center here in the UK specializes in additive, subtractive, and hybrid manufacturing methods. Although each technology center has a different focus, they all operate under an open innovation sharing philosophy. Our residents share what they've learned with each other and with us. Nurturing new technology by hosting residents and by cross-fertilizing ideas is what I mean when I say that Autodesk cultivates innovation. But this approach is not unique to Autodesk. Some of you are doing this too. I'll give you a quick example. In February this year, I met this man, Rolando Mendoza, at a conference on industrialized construction. Rolando told me that he uses the construction sites that he operates as open-air innovation laboratories to prove out new technology. Rolando is the director of virtual design and construction for an American construction firm, Mortenson. And that's his laboratory. It's one of many. His company is building half a dozen projects like this at any given time. He was at the construction conference looking for the next technology to prove out. He and I were both very intrigued by a startup called Dusty Robotics. They were developing a mobile printer to paint wall layout lines on concrete slabs. This is the concept printer from their website. Now fast forward 3 short months, and here are the Mortenson folks and the Dusty team at a football stadium that Mortensen is building in Las Vegas. Now, I'm talking about the kind of football where there is very little contact between the foot and the ball. American football. This new stadium will have a retractable grass field, a self-cleaning transparent roof, and 160,000 square meters of concrete floor. Less than 1% of that floor, just 150 square meters, became the Open Innovation Laboratory. Mortensen cordoned off this space for the founder of Dusty Robotics, Tessa Lau, so she and her team could complete the biggest automated layout that they had ever attempted. On a Saturday morning at 7 o'clock, Tessa's printer painted wall layout lines for 3 luxury suites in the stadium. As the lines took shape on the floor, we all gathered around to inspect the printout. The CAD drawings that Mortensen had provided had been clearly laid out on the concrete. The field test was a success. The printer knew what to paint because it used the lines that were extracted from Revit. An off-the-shelf survey tool, a total station, told the robot where to paint. Now, the following week, Mortensen's subcontractor laid out that same space. They also used a total station to locate points, and then they snapped chalk lines. Their layout confirmed what the Dusty team suspected. The field printer's layout was right on target. As you can see in this image, the blue chalk lines landed right on the black printed lines. According to Mortensen Construction's construction manager, who was at the test, his framing crews could build off the printed lines. It was a watershed moment for him. He could now see into the near future when he had a device that knew its location on a construction site and would make his subcontractors' work more accurate, less error-prone. In fact, the subcontractors showed up at the field test. They came on their day off to observe, and they liked what they saw, which surprised me because I thought they would see the device as a threat to their job security. After watching the printer paint lines for an hour, they determined it could potentially speed up layout. It could eliminate the need for math in the field, simple addition and subtraction. Reserving less than 1% of their construction sites as proving grounds for new technology is helping Mortensen build projects better. They're documenting what they learned from this test and applying it in another month on a future test, on a future site. By cultivating innovative technology like the field printer, Mortensen is giving their layout teams the opportunity to do their jobs in less time, enabling their wall framers to do their job with more precision and accuracy and less waste, less rework. So I've told you how Autodesk collaborates to innovate, and I've shown how the Autodesk residencies and the Mortensen field tests help cultivate innovation by providing opportunities to prove out new technologies. Next, I'll share an example of how you can catalyze change in your industry, how you can innovate in your field by pushing Autodesk tools in new directions. Artists push tools in new directions all the time. The artist Joris Larman catalyzed the invention of large-scale metal 3D printing by pushing robotic welding in new directions. The artist Madeline Gannon used computer vision and closed-loop control to catalyze the creation of interactive robotics. My last story this morning is about someone who pushed generative design in new directions to catalyze the creation of something sublime. This story starts with a simple design question. Can you find a structure to rest our bodies using the least amount of material? It's the question that renowned French designer Philippe Starck asked Autodesk's generative design tool. And our tool's response was this: a chair that is as beautiful as it is comfortable. The first commercially available piece of furniture created by artificial intelligence. Now, that's the story you may have read online, but the story is more nuanced, as you can imagine. Yes, Philippe Starck is the visionary creator behind this sublime chair. And Starck mentored the algorithm to suitable results. But just how did our generative design tool produce a chair that is both beautiful and manufacturable, that's novel and yet true to Starck's aesthetic, and that's suited for mass production? Let's back up to when Starck first encountered generative design. He had high expectations for our system. He imagined being able to describe what he wanted in words, and a fully realized design would take form. And being the conceptual thinker that he is, he described what he sought as something like nature, driven by economy, hazard, and need. Now, as good as AI is at interpreting human speech, it will be quite some time before it's able to take economy, hazard, and need and create something as beautiful as this chair. So Starck's design team, which included a design researcher from Autodesk Research, they circled around those inspiring yet abstract requirements for weeks. They stalled out. They didn't know how to push those ideas into the tool. The breakthrough came when Starck provided minimal lines for a comfortable chair. These lines captured the essence of a Starck chair. They served as the initial geometric constraints for generative design, and they included a minimal seat surface, minimal back and arm supports, and the points of contact between the floor and the chair. With the constraints defined, next came the functional goals. The goals for this chair were to use minimal material, support a human, and be manufacturable through injection molding. These specific goals, plus the constraints, were enough to jumpstart the system's brain, and it began kicking out solutions. It was then that the Autodesk design researcher started exploring the solutions on Starck's behalf. And he saw that he needed to beef up the leg constraints, those rectangles that you saw, because producing crisscrossing legs would not be possible. You cannot injection mold something with crisscrossing legs. Now, here's an example of a first-generation design. Starck's critique of these designs, the initial generations, was brutal. He said they were either too robotic or too scary. So the algorithm had solved for the functional requirements, but was blind to the emotional aesthetic. So the Autodesk researcher adapted the constraints to drive the system toward more slender struts and less blocky proportions. Working back and forth with the system, Starck and the researcher continued until Starck was confident in the chair's minimal aesthetic. Our generative design tool made him confident in how the chair would perform, not just in terms of strength, but also manufacturability. Because the algorithm had optimized the wall surface that forms the hollow interior of the chair, and it optimized the chair's overhanging angles. Walls that are too thick cost too much, walls that are too thin risk collapse, and overhangs risk the chair failing to release during production, which renders a €1 million mold worthless. And so these beautiful curves are there for a reason. They reflect Stark's aesthetic, and they reflect his knowledge of injection molding. We can apply this insight within Fusion 360 to offer similar performance to our customers in the future. Now, Philippe Starck pushed generative design in a direction that we hadn't imagined. Our initial idea for generative design was to optimize for structural performance. But he pushed the tool toward optimizing for aesthetics and injection molding. By pushing the tool, he helped catalyze our thinking about what generative design could be. He helped us explore new opportunities for how generative design could better make things that are strong, sublimely beautiful, and manufacturable. Whether your field involves building bridges, laying out walls on construction sites, or making consumer products, it's not a lack of ideas or creativity that stifles innovation. What's difficult is executing on those ideas. Scott's design studio is quite capable of generating creative ideas, but it's how open Scott was to collaborating with other researchers and robots that's helping him execute on the assembly of this complex bridge. And just as Mortensen opens up 1% of their construction sites to help cultivate the conditions where innovative startups like Dusty Robotics can prove out their ideas, Autodesk opens the doors to our technology centers to cultivate budding projects in a resource-rich environment. And while creativity is no doubt a key ingredient in Philippe Starck's recipe for innovation, pushing our generative design tool in new directions is doing more than executing Stark's design ideas. He's catalyzing a new AI-assisted approach to furniture design. At Autodesk, we work with you, our customers, in many different ways to create new and useful tools. Because despite our innovative ideas and our creativity, it's you, our customers, who shape our ideas into something that adds value, giving you the opportunity to make better things in better ways and do better work. Thank you. Now go open some doors at AU.